So question 12 reads, given the curve y is equal to x minus 1 to the power 3, and the line L is equal to 3y plus x equal to 0, find the equation of all lines that are tangent to the curve, 1. And the condition is that those lines tangent to the curve should also be perpendicular to the line given. Now, two perpendicular lines are, first to start with, we are saying a line is said to be perpendicular to the other line if the gradients of the two lines, say line 1 and line 2, the product is equal to -1. Then we say that those two lines with gradients M1 and M2 are perpendicular. Now here we are given that from this line, 3y plus x equal to 0, we can write it as 3y equal to -x, meaning y equal to -1/3x. So what is the gradient here? The gradient m is equal to -1/3 for this given line. Now we want to find the lines that are perpendicular to this line, meaning their gradients should be, when we bring here, so we're going to have m1 -1/3 should be equal to -1. So if we multiply by -3 and by -3 on the other side, we're going to have m1 equal to +3. So we want the lines that are perpendicular to this line to have this gradient. M1 is equal to 3. That's the first thing to do. The second thing now is we need to go to y equal to x minus 1 to the power 3 and find the lines now. Okay, the lines that are what? That are tangent to that curve. So we'll do this on the board. Okay, so we're going to have the curve y. Okay. The curve y. So this is question 12. So the curve y is equal to x minus 1 to the power 3. So we'll differentiate this guy. Squared. So when we differentiate, this dy dx is the gradient equation. Now we want the gradients to be equal to 3. The 3 we got on the other page. So now we are going to have, when we divide by 3, we'll have x minus 1 to the power 2 equal to 1. Square root. So we'll have x minus 1 equal to plus or minus 1, meaning we'll have x is equal to 1 plus or minus 1, meaning x is 2 or x is 0. So x is 2 or x is 0. Okay, so we go back to y, substitute 2. So we'll have 2 minus 1 to the power 3, which is equal to 1. So we're going to have a point x naught comma y naught, which is 2 comma 1. And another one, x naught comma y naught, which is 0 comma. We get 0 and substitute it in y. This will be -1. So 0 comma -1. So these are the points that you're going to remember. A line is y minus y naught equal to m x minus x naught. So we have 2 points where the tangent lines are going to pass, meaning you're going to have at least two lines. So we'll get the first line will be y minus, from this point, 1 equal to m. What is our m? Remember, m should be 3 because they should be tangent to this and also perpendicular to the line. Which line? The line 3y plus x equal to 0, which we resolved to y is equal to -1 over 3x, like that. So y minus 1 equal to 3x minus 2, which will be y equal to 3x minus 6 plus 1. So y will be 3x minus 5. That's the first line. Then the other line, y minus -1 equal to m. What's our m? Our m is 3, x minus 0. So this will be y plus 1 equal to 3x, which is going to be y is equal to 3x minus 1. So we get these 2 lines. This one and this one. So these are the lines that we get. Any questions? Okay, no questions. We can move the next. That was 12, so we go to 13. What's question 13? Question 13 is, find the equation of the tangent to the curve. So here is the curve. The equation of the tangent to the curve, this, that is parallel to the x-axis. So there is always a very big number of tangent lines to any curve. Now this question has specified they want only the tangents to the curve that are also parallel to the x-axis. Now you agree with me that the x-axis is a horizontal line. So the gradient of the horizontal line is 0. Any horizontal line has a gradient of 0. So I want to find the lines are a tangent to that curve that are parallel to the x-axis. So meaning that those lines should have the same gradient as the x-axis. 2 lines are parallel if and only if they have the same gradient. So in this case, question 13, we'll have f prime of x, we differentiate it and get 1. And this can be written as x plus 4x minus 2 So it will be 1 minus 8x to the power minus 3, which is 1 minus 8 over x power 3. And then we equate this gradient equation, we equate it to 0. Okay, so I want to equate this guy to 0. 1 minus 8 over x3 equal to 0. Meaning x power 3 is equal to 8. So x is equal to 2. So we get 2 and take it in the original function. We'll get 2 plus 4 over 2 squared, which is 2 plus 1, which is 3. So this 3 is the y coordinate. So now we have a full point, 2, 3. And so we'll get y minus 3 is equal to 0 as the gradient, and then x minus 2, which is just y minus 3 equal to 0. So we'll get y is equal to 3 as the required line. So that line is tangent to the given curve and also parallel to the x-axis. So get the key point. Any two parallel lines, they have the same gradient. The gradient of the horizontal line is always equal to 0. Okay, so we move to question 14. Yeah. Question 14. Find all the points on the curve at which the tangent is perpendicular to the x-axis. You guys, perpendicular, if this is the x-axis, the line perpendicular should form a 90 degrees when they cross with the x-axis. So it will be a vertical line. Now, vertical lines do not have gradients. The vertical line has undefined gradient. So what we'll do is this. We'll get our function, differentiate it. Okay, we'll get 2x plus half 1 minus x squared to the power minus half multiplied by minus 2x. Like that, which is equal to 2x. So this 2 and that 2 cancel. So it will be 2x minus x over the square root of 1 minus x squared. Like that. You see this? For this to have, this is the gradient equation. So for this to be undefined, remember, the vertical line should have undefined gradient. And now we want to find all points on the curve at which the tangent is perpendicular to the x-axis. So the tangent must be vertical, meaning it should have undefined gradient. So here we say, to make this equation undefined, this function, to make it and this dy dx, to make it undefined, we would demand that 1 minus x squared root is equal to 0. Since it's a denominator, so once the denominator is 0, then nothing is undefined. So when you square and square, we'll get x squared equal to 1, meaning x should be plus or minus 1. So we take x, the original function. What will be y? So we'll have y equal to, when x is 1, we'll get 1 plus the root of 1 minus 1, which is just 1. So we're going to have 2 points. Point 1 will be 1, 1. Point 2 will be negative 1, 1. Because even if I bring a negative 1 here, I will square it. So I'll get the same value. So it will be 1, 1 and negative 1, 1. So the question says find all the points. So I found there are 2 points. Point 1 is 1, 1. Point 2 is negative 1, 1. So I hope we don't miss that one. You got it correct. Well, so what I'm saying is you differentiate. Why do we differentiate? We differentiate because the first derivative is the gradient equation, the gradient of the tangent line. If the question was asking us to find the normal, we would have used the relationship between the tangent, the gradient of the tangent and the gradient of the normal to find. We don't go directly to the first derivative. We use the other relationship. But you would first need to find the tangent gradient, which is found from the first derivative. Any questions this far? Oh, no questions, so we can move. So that was question 14. Okay. So where are we now? We're on question 15. Question 15 is mostly a very nice question to answer. You only take less than a minute if you're in a test. What do you need? The first thing, use linearization to approximate the value. So linearization has a formula. What's the formula? The formula is here. So we're getting LX is going to be f of A plus f prime of A multiplied by x minus A. Okay, maybe let me write it. In such a way that it will fit. So it's FA plus f prime of A x minus A. So where is A coming from? So if you look at part A, we are given the root of 80. So this 80 is called the x. A is the value that is close to 80, but it has a perfect square root. Because the function is a root function, so we need A that has a perfect root. So the closest number to 80 is 81. Okay, so what will be our f? Our f of x is going to be root x. So we differentiate. So this is x to the power half. So we differentiate. F prime of x is equal to half x, half minus 1, that's minus half. So this can be written as 1 over 2 root x. Then now we substitute in the function. So before we substitute, we can find FA. FA will be F81, which is root 81 which is 9. Okay. So now we'll go to Lx. Lx is equal to Fa, which we have found to be 9, plus what is f prime of A? It's 1 over 2 by 9 multiplied by x. What is x? X is 80 minus A, which is 81. So get 9 plus 1 over 18 multiplied by -1. So you should be able to simplify this. This will be 9 by 18 minus 1 over 18. So this should be the approximate value of root 8, this one. I think it should get down to 8.94 if you round off when you check. Okay. So we can do, I think we can do B a similar manner. Your A will be 64. The first B, so the other B I think this should be C. So for C, what will be your A? I think A for C, so I'll just guide. A for B is 64. And A for this should be 243, I think. Yeah, because you need a number which has the known fifth root. And then after you get that known fifth root, then you would get the square of it and then subtract by 1 as your f of A. And then the same thing as your f prime of A, though the 1 will disappear in the f prime. And then your x minus A, that is always 124 minus the A now being 243. And then you see that the value always makes sense. So what we do question 16. So question 16 says find the linearization of this guy at 3, 0 and use it to estimate y when x is equal to 2.98. Okay, so linearization is the same. It says f of A plus f prime of A x minus A. That's simple. So f of A is already known. Since our A is, we want to use 3. So when our A is 3, our f of A is 0. So it means that f of A is 0 plus f prime of A. So now we come here. F prime is dy dx. So we differentiate using implicit differentiation. So get ey dy dx and then plus dy dx multiplied by x minus 2 and then plus y equal to 2x. And then substitute a there. So substitute where there is x, we'll put 3, where there is y, we'll put 0. So we're going to have dy dx plus 3 minus 2, that's 1. That will be plus dy dx again. And then plus y is 0 equal to 2x, that will be 6. So meaning we'll have dy dx equal to 3. So it means that f prime of a is equal to 3 and then x minus a. So we have used a as 3. Then part 2 says, and use it to estimate y when x is equal to 2.98. Now we have found x. So we'll say, okay, so when x is equal to 2.98, we're going to have this guy approximated as 3, 2.98 minus 3. So you should check the value. You can compute this using a calculator, just punch in the numbers. That's question 16. Then we have question 17 coming after the break. So the break is for 10 minutes. And then we'll get back and do question 17.